So to figure out how much work is extracted from a rapid process, we're going to consider the following case. So let's consider the expansion in a gas inside a vertical piston cylinder that has initially a 1 kilogram block on it. Okay? Alright, and so let's draw out our system. Alright, so here's the cylinder, here's the piston, and it has a 1 kilogram block on it, and underneath the piston is our gas. Okay. Alright, so this is going to be state 1, and in the initial state, the system is at some pressure 1, and the gas has a volume which we'll say is equal to 0.1 meters cubed. Okay? Alright, and so this is the initial state of the gas. And then what we're going to do to the system is we're going to remove that block. And by removing the block, that allows the piston to move up and the gas to expand. Okay? And let's say that, after the block is removed, the gas now has pressure 2, and it also has another volume, which we'll say is 1 meter cubed. Okay? Alright, and so by removing that block, that allows the gas to expand. And we're going to say it expands rapidly. And so the question that we have is going to be, what is the work exerted by the gas during this rapid expansion? Rapid expansion. Okay? Alright, and so during this expansion, or at the end of the expansion, both the pressure and the volume of the gas are changing. Okay? And so to help at least simplify our analysis, what we're going to do is when we analyze this process, or when we mathematically model this process, what we're going to do is we're going to break it up into 2 steps. Or we're going to think of it occurring in 2 steps. Right? And so in our first step, what we're going to say that happens is that the pressure is decreased, so that pressure 1 goes to pressure 2, right? But as the pressure decreases, the volume of the system is going to stay the same. So V1 stays at V1. Okay? So we're going to say only the pressure changes at first. And then after that pressure changes, what we're going to do is then say that the volume increases in the second step. Pressure decreases, and then in the second step, the volume increases. So volume 1 goes to volume 2, but the pressure of the gas, P2, stays at P2. Okay? Alright, and so we're breaking up our process into 2 steps. Right? And so to figure out the total amount of work that's performed, we got to figure out, what happens during these 2 steps. Okay? Alright, and so to figure out pressure 1 and pressure 2 in step 1, what we need to do is we need to consider the forces that are acting against the gas at both the pressure 1 and pressure 2 state. Okay? And so to figure out P1 and P2 in step 1, we need to apply our force balances. Okay. All right. And so in state 1, when we apply our force balance, what we should do is we should draw our free body diagram. So here's the piston, right? And the gas is beneath the piston, and the gas is colliding and hitting that piston, and so it's applying a force in the upward direction. In the downward direction, we have 3 different forces acting on the piston. We have the atmospheric force, which is due to the atmospheric molecules colliding with the piston. We also have the weight of the piston acting in the downward direction. So the weight is going to be equal to the mass of the piston times the gravitational acceleration. And we also have the weight of the block acting in the downward direction. Okay? And so these are the different forces that are acting on the piston. And so for the force of the gas, similar to what we did in chapter 3, we could just say that's the pressure of the gas times the area of the piston. In the downward direction, that's just going to be the atmospheric force, which is atmospheric pressure times the area of the piston, plus the mass of the piston times gravity, plus the mass of the block times gravity. Right? In fact, we could factor out the gravitational acceleration as well to write it like this. Right? And in the initial state, before we remove the block, we know that the piston is not moving. Right? And so since piston is not moving, we know that the force of the gas is going to equal the force in the downward direction. Okay? And so force of the gas we know is this. Force in the downward direction we know is this. And if we solve for P1, we get this relationship. Okay? Gravitational acceleration. All right, so that's the pressure of the gas in state 1. In a similar manner, we could also apply this analysis to figure out what the pressure of the gas is going to be in state 2. Okay? And so if we draw our free body diagram again, in state 2, we also have a force of the gas acting in the upward direction. But in the downward direction, we're going to have fewer forces acting than what we had in state 1. So in this case, we only have the atmospheric force and then the weight of the piston. Okay? And so F gas equal to P2 AP, because now we're talking about the pressure in state 2. The force down is going to be the atmospheric pressure and the weight of the piston. Okay? And so if we think of the pressure of the gas that's going on in the system, that pressure, of the gas, we could also apply a force balance as well. And so the force of the gas is going to equal force down you solve for pressure 2, you have this. Okay? So this is pressure 2. And if we compare it to pressure 1, pressure 1 has this additional block term that pressure 2 is missing. And so that tells us that pressure 2 is going to be less than pressure 1.